In the last class we discussed mole concept and atomic mass unit. Okay, what is one atomic mass unit? And one atomic mass unit is equal to 1.66 into 10 power minus 24 grams, or in kgs it is 1.66 into 10 power minus 27 kgs. Okay, right. For example, what is the mass of one hydrogen atom? And mass of one hydrogen atom is one atomic mass unit. One atomic mass unit indicates mass of one hydrogen atom, whereas 1 gram indicates mass of how many hydrogen atoms? Mass of Avogadro number of hydrogen atoms. One atomic mass unit is the mass of one hydrogen atom, that is 1 into 1.66 into 10 power minus 24 grams, that is the mass of one hydrogen atom, whereas 1 gram is the mass of Avogadro number of hydrogen atoms. Next we discussed 1 mole. Mole means it is the amount of substance that contains Avogadro number of particles. Okay, how many particles present in 12 grams of carbon? How many particles present in 12 grams of carbon? Okay, to get same particles, same number of particles, what is the amount of substance required? That is called 1 mole. In 12 grams of carbon, how many particles we will get? How many carbon, number of carbon 12 atoms in 12 grams of carbon? We are taking 12 grams. What is the mass of one carbon atom? 1.9924 into 10 power minus 23. So if you simplify this, we will get 6.02 into 10 power 23. So in 12 grams of carbon, how many carbon 12 atoms are there? 6.02 into 10 power 23 carbon atoms are present. That is nothing but Avogadro number. Okay. So to get same number of particles, what is the amount of substance required? That is called 1 mole. How to calculate number of moles? Weight by, okay, gram molecular weight. Gram atomic weight, okay, or molar mass, right. Next one, if number of particles is given, number of particles by Avogadro number, right. Or if volume in liters given under STP or NTP conditions, volume in liters by 22.4, volume if given in ml by 22,400 in liter or decimeter cube, here in ml or centimeter cube. Okay, pressure under NTP or STP conditions. Okay, if you take NTP conditions, pressure 1 atmosphere, temperature 0 degree centigrade. Temperature is 0 degree centigrade. Okay. So next we discuss various methods to express concentration of a solution. Various methods to express concentration of a solution. Right. Various methods to express concentration of a solution. Various methods to express concentration of a solution. So what are the various methods we have to express concentration of a solution? So these are the various methods we have. One is mass percent, okay, which is indicated like this, weight by weight percentage, mass percentage. Next one, volume percent, V by V percent. Next, weight by volume percent, weight volume percent, weight by volume percent. Next one, mole fraction X, mole fraction. Next to molarity capital M, molality small m, molarity. Next one, parts per billion we have, parts per billion, parts per million, parts per billion, and we have normality. Strength also we have, strength of a solution, strength of a solution, and formality also we have, formality we follow for ionic solids. Okay, these are the various methods we have to express concentration of a solution: mass percent, volume percent, weight volume percent, mole fraction, molality, parts per million, parts per billion, normality, and strength. In that first put heading mass percent, mass percent. So weight by weight percent. Okay, we know solution means what? Solute plus solvent. Okay, solution means solute plus solvent. Okay, so here the numerator corresponds to solute and the denominator corresponds to solution we will get. Okay, so mass percentage is nothing but it is the amount of solute in grams present in 100 grams of solution. Okay, percent means how many grams of solution you have to take? 100 grams of solution. In 100 grams of solution, how many grams of solute present? That is called mass percent. Okay, we have to take 100 grams of solution. Percent means in 100 grams of solution, how many grams of solute present? That is called as mass percent. Right? It is the amount of solute. It is the amount of solute. It is the amount of solute in grams. It is the amount of solute in grams. It is the amount of solute in grams present in 100 grams of solution. It is the amount of solute in grams present in 100 grams of solution. Let us consider, for example, capital W grams of solution I am taking. In capital W grams of solution, let us consider small w grams of solute present. In capital W grams of solution, small w grams of solute present. Now weight by weight percentage means for how many grams of solution we have to calculate it? 100 grams of solution we have to calculate. Then what is the weight of solute present in 100 grams of solution? What is the weight of solute present in 100 grams of solution? That is called weight by weight percent. So weight by weight percent is equal to, okay, what we get, Andy? This one by this one into this one. Okay, that means weight of solute in grams, weight of solute in grams by what we get? Weight of solution in grams. Okay, this one by this one into 100. This is the formula for weight by weight percentage or mass percent. Weight of solute in grams by weight of solution in grams into 100. So that's why I told you numerator corresponds to solute, denominator corresponds to solution, percentage means into 100 we will get. Simply remember like that. Okay. Is there any unit or no unit? No unit. Here we are expressing in grams. This is also we are expressing in grams. No unit. Okay, no unit for weight by weight percentage. Next, whether it depends on temperature or independent of temperature. Depend or independent? Independent of temperature. Whenever we are using weights that depend independent of temperature, and if you use volume, then it depends on temperature. Okay, if you write the temperature, what happens to volume? Volume changes or not? If you increase the temperature, volume increases. If you decrease the temperature, volume decreases. So based on that, whenever temperature changes, volume changes, concentration also changes. If concentration term involves volume, then it depends on temperature. If concentration term involves weights, if you write the temperature, is there any change in the weight of substance or no change in the weight of substance? No change in the weight of substance. So whenever concentration terms involves weights, that is independent of temperature. Okay, for example, I am giving 2% weight by weight, 2% weight by weight, Okay, NaOH solution, 2% weight by weight, NaOH, aqueous NaOH solution, 2% weight by weight, aqueous NaOH solution. What is the meaning of this? How many grams of NaOH present in 100 grams of solution? 2 grams of NaOH. So the meaning of that is 2 grams of NaOH present in 100 grams of solution. So therefore weight of NaOH is equal to what? 2 grams. What about weight of water and aqueous solution we are taking? 2 grams is NaOH, the remaining is what? Water. So therefore total solution weight is 100 grams. Okay. The weight of NaOH is 2 grams, weight of water 98 grams. Okay, so we get 100 grams solution. For example, if 5 grams of NaOH, 5 grams of NaOH present in, 5 grams of NaOH present in, okay, 250 grams of aqueous NaOH solution. For example, 5 grams of NaOH present in 250 grams of aqueous NaOH solution. Then what is weight by weight percentage? Weight by weight percentage is equal to what? Weight of solute, that is 5 grams by weight of solution. What is the weight of solution? 250 grams into 100. Okay, how many times gets cancelled? 5. Okay, so therefore what we are getting? 2% we are getting again, 2%. If 5 grams of NaOH present in 250 grams of aqueous NaOH solution, what is its weight by weight percentage? That is 2%. This is mass percentage. Okay, no unit, it is independent of temperature. Similarly, now you tell me what about volume percentage? Volume percent, V by V. Again, numerator corresponds to solute, denominator corresponds to solution, into 100 we will get per percent. Volume percentage. What? It is the volume of solute. It is the volume of solute in ml present in 100 ml of solution. In 100 ml of solution, how many ml of solute present? In 100 ml of solution, how many ml of solute present? That is called as volume percent. Right? It is the volume of solute. It is the volume of solute. It is the volume of solute in ml. It is the volume of solute in ml present in. It is the volume of solute in ml present in 100 ml of solution. It is the volume of solute present in 100 ml of solution. 100 ml of solution. Okay. For example, in VML of solution, in capital VML of solution, let us consider small VML of solute present. In VML of solution, small VML of solute present. Then we have to calculate for how many ml of solution? 100 ml of solution. So in 100 ml of solution, what is the volume of solute present? In 100 ml of solution, what is the volume of solute present? That is called what? Volume percent. So therefore V by V percentage is equal to what? Volume of solute in ml by volume of solution in ml into 100. Okay, right. So numerator corresponds to what? Solute, and the denominator corresponds to solution. Volume of solute in ml by volume of solution in ml into 100. For example, I am giving like this: 10% V by V, 10% V by V, aqueous HCl solution. 10% V by V, aqueous HCl solution. 10% V by V, aqueous HCl solution. So what is the meaning of this? 10 ml of HCl present in 100 ml of solution. 10 ml of HCl present in 100 ml of solution, right? What is the meaning of this? 10 ml of HCl present in 10 ml of HCl present in 100 ml of solution. 10 ml of HCl present in 100 ml of solution. Therefore, what is the volume of HCl? 10 ml. Volume of water 90 ml. So, total volume of solution is 100 ml. So, volume of HCl is 10 ml, volume of water is 90 ml. So, total volume is 100 ml. Total volume is 100 ml. Okay, now volume of HCl 10 ml, volume of water 90 ml. Now, solution volume is 100 ml. Okay. For example, 25 ml of 25 ml of ethyl alcohol. For example, 25 ml of ethyl alcohol present in 25 ml of ethyl alcohol present in 500 ml of aqueous solution. 25 ml of ethyl alcohol present in 500 ml of aqueous solution. What is its volume by volume percent? Volume percent. What is its volume percent? 25 by 500 into 100, right? That is 5%. In 500 ml, 25 ml means in 100 ml, how many ml is presented? 5 ml is present. Okay, 5%. Okay, whether it depends on temperature or independent of temperature? It depends on temperature. With change in temperature, volumes may changes. So therefore, it depends on temperature. If you express concentration with respect to volume, it depends on temperature. Third one, weight by volume percent. Weight by volume percent. So numerator corresponds to what? Solute. Denominator corresponds to solution. So how can you define weight volume percentage? It is the weight of solute or amount of solute in grams present in 100 ml of solution. Okay. Solution we are expressing with respect to volume, solute we are expressing with respect to weight. Okay. So in 100 ml of solution, what is the weight of solute present? In 100 ml of solution, what is the weight of solute present? That is called weight volume percent, right? It is the amount of solute. It is the amount of solute in grams. It is the amount of solute in grams. It is the amount of solute in grams present in. It is the amount of solute in grams present in 100 ml of solution. It is the amount of solute in grams present in 100 ml of solution. Let us consider in VML of solution. Let us consider in VML of solution W grams of solute present. In VML of solution, W grams of solute present. Now we have to calculate for how many ml of solution? 100 ml of solution. In 100 ml of solution, how many grams of solute present? That is called weight by volume percent. So that is equal to, what we get it? Weight of solute in grams, weight of solute in grams by volume of solution in ml into 100. Weight of solute in grams by volume of solution in ml into 100. Whether it depends on temperature or not. Yes, we are expressing with respect to volume, so it depends on temperature. It depends on temperature. It depends on temperature. Okay, for example, I am giving 10% weight by volume aqueous NaOH solution. 10% weight by volume aqueous NaOH solution I am giving. 10% weight by volume aqueous NaOH solution. What is the meaning of this? 10 grams of NaOH present in 100 ml of solution. 10 grams of NaOH present in 100 ml of solution. So we have to take 10 grams of NaOH and we have to make up to 100 ml. Okay, we have to take 10 grams of NaOH and we have to make up to 100 ml. Okay, right, 10 grams of NaOH present in 100 ml of solution. For example, 5 grams of, okay, for example, 5 grams of sodium carbonate present in 5 grams of sodium carbonate present in, okay, 200 ml of aqueous solution. For example, 5 grams of Na2CO3 present in 200 ml of aqueous solution. What is its weight by volume percentage? In 200 ml 5 grams means in 100 ml how many grams? 2.5 grams. So its weight by volume percentage is 2.5. Otherwise 5 by 250 into, sorry, 200 into 100. So we get 2.5 percentage. So we get 2.5 percentage. So this is weight by volume percentage. Fourth one, mole fraction. Mole fraction or mole percent. Mole fraction or mole percent. Okay. What you are expecting? What you are expecting? ml, right? Gram per ml. Unit gram per ml. Okay. So mole fraction. Mole fraction. Mole fraction is nothing but what? It is the ratio of. It is the ratio of number of moles of solute to total number of moles of all components present in the solution. It is the ratio of. It is the ratio of number of moles of a component. It is the ratio of number of moles of a component. It is the ratio of number of moles of a component to number of moles of all components to number of moles of all components present in the solution. Present in the solution. So mole fraction is the ratio of number of moles of a component to the number of moles of all components present in the solution. For example, if you consider a two component system, A comma B, if you consider a two component system A comma B and the corresponding number of moles Na comma Nb, we are taking a two component system A comma B, the corresponding number of moles Na comma Nb, then mole fraction of A is given as number of moles by total number of moles. So number of moles of A by total number of moles, and mole fraction of B is given as Nb by Na plus Nb. What about the sum of the mole fractions? 1. Sum of the mole fractions is equal to always 1. Na plus Nb by Na plus Nb. If 60% of A is present in the solution, 40% of B present in the solution. So mole fraction of A 0.6, mole fraction of B 0.4. So always the sum of the mole fractions of all components present in the solution is equal to 1. Write that point. Sum of the mole fractions of all the components present in the solution, is always 1. Okay. For example, if you take a three component system, how to give the mole fraction of A? Number of moles of A by total number of moles. Number of mole fraction of B, number of moles of B by total number of moles. Mole fraction of C, number of moles of C by total number of moles. And always sum of the mole fractions of all the components present in the solution is equal to 1. That is XA plus XB plus XC is equal to 1. What about limits for mole fraction? We discussed in thermodynamics. Limits for mole fraction are what? 0 to 1. Limits for mole fraction are 0 to 1. For example, if you take pure A, in pure A, what is the mole fraction of A? 100% A we have. So that is A, 1. In pure A, what is the mole fraction of B? 0. Okay, what is the mole fraction of C in pure A? 0. So what are the limits for mole fraction? 0 to 1. Next one. What about unit for mole fraction? Number of moles by number of moles. And is there any unit or no unit? No unit for mole fraction. No unit for mole fraction. No unit for mole fraction. Next, whether it depends on temperature or independent of temperature. Are we expressing with respect to volume? No. So therefore it is independent of temperature. Mole fraction is independent of temperature. Mole fraction is independent of temperature. Okay, this is the concept of mole fraction or mole percent. Okay, it is the ratio of total number of moles, number of moles of a component to total number of moles, that is called mole fraction of that component. Always sum of the mole fractions is equal to 1. And the limits for mole fraction are 0 to 1, no unit for mole fraction, and it is independent of temperature. So next one, molarity. Molarity. What is molarity? It is the number of moles of solute present in 1 liter solution. It is the number of moles of solute present in 1 liter solution. If you take 1 liter solution, how many moles of solute present? Okay, that is called molarity. Or it is the number of millimoles of solute present in 1 ml solution. If you take 1 liter, how many moles are present? If you take 1 ml, how many millimoles are present? Okay, that is called molarity. Write the definition. It is the it is the number of moles of solute. It is the number of moles of solute. It is the number of moles of solute present in. It is the number of moles of solute present in 1 liter solution. It is the number of moles of solute present in 1 liter solution, or it is the number of millimoles of solute. It is the number of moles of millimoles of solute present in 1 ml solution. It is the number of moles of solute present in 1 liter solution, or it is the number of millimoles of solute present in 1 ml solution. It is the number of millimoles of solute present in 1 ml solution. So for example, in V liter solution, okay, n moles of solute present. In V liter solution, how many moles of solute present? N moles of solute present. Now we want to calculate for how many liters? 1 liter. Okay, we want to calculate for 1 liter. So in 1 liter solution, how many moles of solute present? If in V liter solution n moles of solute present, then in 1 liter solution how many moles of solute present? That is called molarity. So molarity is equal to what we get? N by V into 1. So number of moles by volume in liters. This is the formula for molarity. Number of moles by volume in liters. For example, 10 moles of solute present in 10 moles of solute present in 10 moles of solute present in 5 liter solution. 10 moles of solute present in 5 liter solution. What is its molarity? And how many moles are present? 10 moles in 5 liters. So what about its molarity? And 0.5 molar. The molarity of the resultant solution is 0.5. Okay. Huh? Yeah. 2 molar. Okay. Right. Next one. What is the unit and unit we can represent by capital M, molarity we can represent by capital M, or this is number of moles, okay, moles and volume in liters. So therefore what we get in moles per liter, or moles per liter we can write as decimeter cube, moles per decimeter cube, or number of millimoles of solute present in 1 ml solution, that is millimoles per ml, and millimoles per ml. Okay, ready? Here if you take millimoles and number of millimoles of solute, if you take volume we have to substitute in what? ml. Okay, this is what number of moles, and n is number of moles by volume in liters, or number of millimoles of solute by volume in ml. One mole is equal to how many millimoles and 10 power 3. 1 mole is equal to how many millimoles? 1000 millimoles. 1 mole is equal to 1000 millimoles. 1 liter is equal to how many milliliters and 1000 milliliters. Same. Okay, these are the units per molarity. Okay, next one, if you see the various expressions for molarity, one is m is equal to n by v in liters. If you convert that into ml, volume in ml into what we get? 1000. Okay, if you convert that into ml, we will get into 1000. In 2000 in the numerator or denominator? Numerator. Okay. So volume in ml is nothing but what? Volume in liters into 1000. Antena? Volume in ml is nothing but volume in liters into 1000. 2 liters means what? 2 into 1000, 2000 ml. 2 liters means how many ml? 2000 ml. So volume in ml is nothing but what? Volume in liters into 1000. So volume in liters we can write as volume in ml by 1000. So volume in liters we can write as volume in ml by 1000. So 1000 will get in the numerator. Okay. So here we have 1 by volume in liters, and reverse will get 1000 by volume in ml. 1000 by volume in ml. Now number of moles we can write as weight by molecular weight. So weight of solute by molecular weight, gram molecular weight, weight of solute in grams by molecular weight in grams. Okay, weight by molecular weight into 1 by V in liters. So number of moles we can write as what? Weight by molecular weight, or weight of solute by molecular weight into, if you write volume in ml, if you substitute volume in ml, we have to multiply with 1000. So out of these various methods, these are important, and mole fraction repeatedly we use mostly what? Mole fraction, molarity and normality. These 4 are relatively important, and mole fraction, molality, okay, molarity and normality. Okay. Next one, and that may be written as molarity is equal to weight of solute by molecular weight into 1000. I am writing as 100 into 10 and by volume of solution. This is what? Volume of what? Solution. We are not writing every time volume of solution. So volume of solution in ml. I am converting molarity into weight by volume percentage. I am converting molarity into weight by volume percent. Weight of solute by volume of solution in ml into 100. What is weight of solute by volume of solution in ml into 100? That is nothing but what? Weight by volume percent. So molarity is equal to weight by volume percent into 10 by molecular weight. So what is the relation between molarity and weight by volume percent? This is the relation. Okay, Andy. Here weight of solute by volume of solution into 100. Weight of solute by volume of solution into 100, that can be written as weight by volume percent. Okay, so next one, from that molarity is equal to weight of solute by molecular weight, into, again I am writing 1000 as 100 into 10, weight of solute by molecular weight into 1000 I am writing as 100 into 10. Next, volume and density of solution is equal to what? And density is equal to what? We have mass by volume. So therefore volume of solution we can write as mass by density. That means weight of solution by density of solution. Okay, 1 by V we have. 1 by V means D by M. 1 by V means D by M. So therefore there we have 1 by V. 1 by V we can write as what? D by M. So density of solution by what? Weight of solution. Density of solution by weight of solution. So weight of solute by weight of solution into 100. What is that? Weight of solute by weight of solution into 100, that is weight by weight percent, mass percent, right? So M is equal to weight by weight percent into 10 into density by molecular weight. So in weight by volume terms, we are not getting that density. Here extra we are getting density and in mass percent. Okay, these are the various expressions we have for molarity. Or in some of the books they have given like this only. Molarity is equal to weight by weight percentage, they have given as purity. Okay, weight by weight percentage given as purity into 10 into specific gravity by molecular weight. Specific gravity is nothing but what? Relative density. And relative density, if it is if the density measured compared to water, almost density of water is 1. So almost relative density, even though it is relative density, it is similar to its density only. Okay, since density of water is almost how much only? 1. Density of water is almost 1. Okay, purity into 10 into specific gravity by molecular weight. Okay, in laboratory we may purchase concentrated solutions, concentrated HCl, concentrated nitric acid, concentrated sulfuric acid. While we are conducting practicals, okay, we need those concentrated solutions or we need dilute solutions. Dilute solutions, we have to dilute. So to dilute, first we have to know what is the concentration of that concentrated solution. In order to dilute, we have to know what is the concentration of the solution we purchased. Okay, so that we can calculate by using this equation. So on that bottle, purity of that solution will be mentioned to you. Some percentage will be given to you, weight by weight percentage will be given to you, into 10 into specific gravity also mentioned on that bottle. So those that purity and specific gravity and molecular weight is known to us, or that is also mentioned on that bottle. So those we have to substitute and we will get the molarity of that solution. Okay, from that we can dilute to our required concentration. Okay, right? So in laboratory, while you are conducting practicals, okay, how to know the molarity of the solution we purchased, concentrated solution we purchased. By using this equation we can calculate it. Okay, right, and the next one, the formula for number of moles of solute. The formula for number of moles of solute. Molarity is equal to what? N by V, number of moles by volume in liters. Now what is the what is the expression for number of moles of solute? So number of moles of solute is nothing but what andi? M into V in liters andi. M into V in liters. The expression for number of moles of solute is M into V in liters. Or if you write like this andi, if you write volume in ml into 1000, then what is the formula for number of moles andi? M into V in ml by 1000. M into V in ml by 1000 or M into V in ml by 1000. So volume in liters is nothing but what? Volume in ml by 1000. Volume in liters is nothing but what? Volume in ml by 1000. Okay, 2 liters we have, for example. 2 liters means what? 2000 by 1000. 2000 ml by 1000. We will get 2 liters. Okay. This is the formula for number of moles of solute. Next one, number of millimoles of solute. Number of millimoles of solute. In JL syllabus we have acids bases also, ionic equilibrium also. There this concept is useful and number of moles, number of millimoles. This is useful while we are discussing acids bases. Okay. Number of millimoles of solute. Number of millimoles means what andi? Number of moles into 1000. Number of millimoles means what? Number of moles into 1000. So number of moles, what is the formula for number of moles andi? M into V in liters, that is number of moles into 1000, or M into V in ml by 1000 into 1000. 1000 gets cancelled, so what we get andi? M into V in ml. What is the formula for molarity andi? The formula for molarity is number of millimoles by what andi? Volume in ml. So number of millimoles is nothing but what andi? Molarity into volume in ml. Molarity into volume in ml. Okay, right. So this is the formula for number of moles and millimoles of solute. Okay. Next one, dilution principle. Dilution principle. Next one, dilution principle. Dilution principle. For example, we have some solution, 1 liter solution, let us consider. We have 1 liter solution in which, for example, 40 grams of NaOH is present. 40 grams of NaOH means how many moles of NaOH? Number of moles is equal to weight by molecular weight. 40 by what is the molecular weight of NaOH? 40. So how many moles of NaOH we are taking? 1 mole. Okay, we are preparing a solution by taking how many grams of NaOH into 40 grams of NaOH. Okay, 40 grams of NaOH present in 1 liter solution. Okay, or 1 mole of NaOH present in 1 liter solution. So what is the molarity and what is the molarity of this solution? 1 or not? Number of moles by volume in liters, 1 by 1. Okay, to this, okay, I am adding 1 liter water. So that means what I am doing and dilution. Dilution means what? Addition of solvent. Addition of solvent is called dilution. For example, here we are taking water as solvent. Okay, so we are adding water in. So now we have how many liter solution? 2 liter solution. Okay, 2 liter solution. In this, what is the weight of NaOH? Now tell me, what is the weight of NaOH here? What is the weight of NaOH present here? 40 grams. What is the number of moles of NaOH present? 1 mole. What is the number of millimoles of NaOH present? 1 mole means how many millimoles? 1000. Number of millimoles of NaOH present is 1000. Now tell me, what is the weight of NaOH present here. Huh? We are adding just water. Is there any change in the weight of NaOH or no change in the weight of NaOH? No change in the weight of NaOH. Again, the weight of NaOH present is 40 grams only. That means what about the number of moles of NaOH present? 40 grams of NaOH means how many moles? 1 mole. Then what about the number of millimoles of NaOH? 1000 millimoles. Number of millimoles of NaOH present is 1000. That means by adding water, is there any change in the weight of solute or number of moles of solute or number of millimoles of solute, or no change? No change in the number of moles or number of millimoles of solute during dilution. That is called dilution principle. What about concentration? Same or changes? Changes. Concentration changes. Here what is the concentration? Number of moles by volume in liters, 1 by 1. That is 1 molar solution. This is 1 molar solution. Here what about the concentration? How many moles present? 1 mole present in how many liter solution? 2 liter solution. That means 0.5 molar. So concentration may changes, but no change in the number of moles or millimoles of solute. That is called dilution principle. Okay, first write this. Right. During dilution, number of moles or number of millimoles during dilution, number of moles or number of millimoles of solute during dilution, number of moles or number of millimoles of solute remains constant. During dilution, number of moles or number of millimoles of solute remains constant. Okay, that is called dilution principle. So we have the formula for number of moles. What is the formula for number of moles? M into V in liters. What is the formula for number of millimoles? M into V in ml. Okay, M into V in liters for number of moles, M into V in ml for number of millimoles. Okay, therefore M into V remains constant. V you may take in liters or milliliters. If you take in liters, number of moles. If you take in ml, that is number of millimoles. So M into V remains constant. What is the formula for number of moles or millimoles? M into V, general expression. So or we can write it as M1 V1 is equal to M2 V2. M into V remains constant. That means M1 V1 is equal to M2 V2. Okay, this equation is useful while we are preparing dilute solutions from concentrated solutions. Okay, this equation is useful. Okay. For example, we have stock solution. In our lab, we have stock solution. Let us consider 10 mHCl we have. What is the stock solution we have? 10 mHCl solution we have. Okay, for our experiment, we need 2 mHCl. For our experiment, what is the concentration of HCl required? 2 mHCl is required. So we can dilute. We have to dilute from 10m to 2m. Okay. This is the stock solution. Our required solution is what? 500 ml of 2m HCl is required. 500 ml of 2m HCl is required. Okay, 500 ml of 2m HCl is required. So what is the volume of 10m HCl we have to take? What is the volume of 10m HCl we have to take? And what is the volume of water we have to add? What is the volume of 10m HCl we have to take, and what is the volume of water we have to add? That we can calculate by using dilution principle. So M1 V1 is equal to, we have M2 V2. What is the initial concentration of HCl? Stock solution 10. What is the volume of such stock solution we have to take, that we want to calculate? Final concentration is 500 ml. So what we are getting? 1000 by 10, 100 ml. So volume of 10 mHCl required is 100 ml. Okay, to prepare 500 ml, that means how much amount of water we have to take? 400 ml of water we have to take. Okay. So here we have to take 100 ml of what? 10 mHCl. 100 ml of 10 mHCl. To that we have to add how much water? 400 ml of water. Okay. What is the resultant solution we get? 500 ml of 2m HCl we will get. 500 ml of 2m HCl we will get. We have to take 100 ml of 10 mHCl. To that we have to add 400 ml of water. So we get 500 ml of 2m HCl. Okay. So therefore volume of water to be added during dilution. Volume of water to be added. Volume of water to be added during dilution. Volume of water to be added during dilution. How much amount of water we have to add? V2 minus V1. Okay, here 500 minus 100. Final volume is 500. Okay, V1 is 100. 500 minus 100, that is 400 ml of water we have to add. So volume of water to be added during dilution is equal to V2 minus V1. Okay. Right. Next one. For example, we are taking two similar solutions. For example, two HCl solutions we are taking. Okay, two HCl solutions of different concentration. Two HCl solutions we are taking, for example, two HCl solutions of different concentration, that is M1 and M2. Let us consider we are taking two HCl solutions having concentrations of M1 and M2. Okay. Now V1 ml of solution 1 plus V2 ml of solution 2 we are mixing, and we are mixing V1 ml of solution 1 and V2 ml of solution 2. Okay, solution 1 concentration is M1, solution 2 concentration is M2. Now we are mixing these two. Okay, this is the resultant solution we have. Okay, V1 ml of solution whose concentration is how much? M1. Here whose concentration is what? M2. Now what about the resultant solution concentration? What about the resultant solution concentration? We are mixing two HCl solutions of different concentration. What is the resultant solution concentration? MR. Resultant solution concentration is, what is the formula? M1 V1 plus M2 V2 by V1 plus V2. M1 V1 plus M2 V2 by V1 plus V2. Okay, in the first solution, what is the number of moles of HCl present? In the first solution, the number of moles of HCl present in the solution, we will get M1 V1. M1 V1 gives what? Number of moles or millimoles. If you take in ml, millimoles. Okay, number of millimoles of HCl present in the first solution. M2 V2 indicates what? Number of millimoles of HCl present in the second solution. In the resultant solution, what is the total number of millimoles of HCl present? M1 V1 plus M2 V2. That it gives number of millimoles of solute. Number of millimoles by what? Volume in ml. What is the formula for molarity? Number of millimoles by volume in ml. What is the total volume of solution? V1 plus V2 ml. That gives total volume. Okay, so like this we can calculate it. For example, we are mixing, okay, we are mixing 200 ml of 5m HCl. For example, we are mixing 200 ml of 5m HCl and 800 ml of, okay, for example, 2m HCl. We are mixing 200 ml of 5m HCl and 800 ml of 2m HCl. What is the resultant solution molarity? What is the resultant solution molarity? So MR is equal to M1 V1, that is 5 into 200. This gives number of moles of HCl in the first solution. Next one, 2 into 800. This gives number of millimoles of HCl present in the second solution. Number of millimoles and in each case. By total volume of solution, that is 200 plus 800. How much you are getting? This is 1000. This is 1600. 2000, 1600 by 1000. That means the resultant solution molarity is 2.6. The resultant solution molarity is 2.6. Now, for example, I am mixing like this. Now I am mixing like this. V1 ml of solution 1 whose concentration is M1 plus V2 ml of solution 2, V2 ml of solution 2, V2 ml of solution 2 whose concentration is M2 plus some X ml of water also I am mixing. I am taking V1 ml of solution 1 plus V2 ml of solution 2 whose concentration is M2, okay, plus X ml of water also I am mixing, and we have resultant solution. This is the resultant solution. This is the resultant solution. What is the resultant solution? Molarity. What is the resultant solution? Molarity. So the resultant solution molarity is equal to, what is the number of millimoles of solute present in first solution? M1 V1. What is the number of millimoles of solute present in second solution? M2 V2. In third one, is it a solution or water? Solvent just we are adding, so no solute present. By what is the resultant solution volume? V1 plus V2 plus X also. V1 plus V2 plus X. So like this we can calculate resultant solution molarity. Okay, to the same question, for example, we are adding, okay, 1600 ml water 200 ml of 5-MHCl, 800 ml of 2-MHCl plus 1600 ml of water we are adding. What is the resultant solution molarity? 1 molar we will get. Here plus 1600. Okay, number of moles or millimoles cannot be changed during dilution. Number of moles or millimoles of solute cannot be changed. Previously 2600 millimoles, now also 2600 millimoles only. No change. Right? So we get 1 molar. So by adding water, no change in the number of millimoles. Previously we have 2600 millimoles of solute, now also 2600 millimoles of solute. Next one, for a reaction, for example, N1 moles of A participated in the reaction with N2 moles of B to give product. And if during a reaction, if N1 moles of A participate in the reaction with N2 moles of B to give product, then what about the ratio of number of moles of A and B? The ratio of number of moles of A and B given as number of moles unit is what? M into V in liters. Okay, M into V in liters. So for first component M1 V1, by second component M2 V2 in liters. So in the numerator if you substitute in liters, in the denominator also you may substitute in liters. Or ratio of number of millimoles M1 V1 in ml by M2 V2 in ml. The ratio of number of millimoles. So you may substitute volume in liters or volume in ml, it will give same. Okay. So the ratio of number of moles of A and B can be given like this. So from this what we get, and in general we get M1 V1 by N1 is equal, if you bring this N1 right side, M2 V2 left side. So M1 V1 by N1 is equal to, we get M2 V2 by N2. So frequently we use this equation, okay, during titrations. Okay, frequently we use this equation during titrations. If one of the solution concentration is known to us, unknown solution concentration we can calculate by using this equation. Okay, for example, HCl versus NaOH, if you take HCl versus NaOH using phenolphthalein indicator, for example, volume of NaOH required, end point is observed, color change is observed, okay, at 10 ml, let us consider. So what is the volume of NaOH required? 10 ml to neutralize HCl. Volume of NaOH required to neutralize HCl is 10 ml. That is the end point. Okay, we took volume of HCl. Let us consider 20 ml. Okay, and molarity of NaOH. Molarity of NaOH is 1 normal. Molarity of NaOH is 1 normal. Now what is the molarity of HCl? Okay, here we are doing titration of HCl versus what? NaOH. HCl versus NaOH, we are using phenolphthalein indicator. What is the end point? And colorless to pink. So pink color is observed at 10 ml, for example. Okay, colorless to pink. So here NaOH solution concentration is known to us. What is the HCl solution concentration? Okay, what is the reaction between NaOH and HCl? NaOH plus HCl gives rise to NaCl plus H2O. This is the balanced equation we have. Now what we have to follow? M1V1 by N1 is equal to M2V2 by N2. One side substitute data for NaOH, another side for HCl. This side for NaOH, this side for HCl. What is the molarity of NaOH given? Normality kaadu, sorry. Molarity kadandi. 1m. Okay, electric layer. 1 into volume of NaOH required, that is 10. Molarity of NaOH, heap 1. Volume of NaOH required for neutralization of HCl is 10. What is the number of moles of NaOH required here? 1. That is equal to M2. Molarity of HCl we want to calculate. Volume of HCl we took for titration, that is 20. Number of moles of HCl is 1 only. So therefore M2 is equal to what? 10 by 20. 10 by 20, that means 1 by 2, that is 0.5 molar. So the molarity of HCl is 0.5. So like this we can calculate unknown solution concentration during titrations. Okay, ready. So here number of moles or number of millimoles of A and B is in the ratio of what? N1 and N2. It may be number of moles or it may be number of millimoles. Right. This is about molarity. And molarity, temperature dependent or independent? And temperature dependent. It is the number of moles of solute present in 1 liter of solution volume. We are expressing molarity with respect to volume. It is temperature dependent. And write that point. It is temperature dependent. Molarity depends on temperature. So next one, sixth method, molality. And molality, small m, molality small m. What is molality? And molarity means it is the number of moles of solute present in 1 liter solution. Molality is it is the number of moles of solute present in 1 kg of solvent. It is the number of moles of solute present in 1 kg of solvent. Right. It is the number of moles of solute. It is the number of moles of solute. It is the number of moles of solute present in. It is the number of moles of solute present in. It is the number of moles of solute present in 1 kg of solvent. It is the number of moles of solute present in 1 kg of solvent. Okay, for example, in W kgs of solvent, in W kgs of solvent, in W kgs of solvent, n moles of solute present. And in W kg of solvent, the number of moles of solute present is N. Then we want to calculate for how many kgs and 1 kg. So in 1 kg of solvent, how many moles of solute present? In 1 kg of solvent, how many moles of solute present? That is called molality, which is represented by small m. So molality is equal to what we get? Number of moles of solute by weight of solvent in kgs. Number of moles of solute by weight of solvent in kg. So the unit is what? Moles per kg. The unit is moles per kg, or simply we represent with small m. We represent simply with small m. Moles per kg or small m. Whether it depends on temperature or independent of temperature. Independent of temperature. We are not expressing with respect to volume. So it is independent of temperature. It is independent of temperature. Okay, right. So we can write this like this also, no? Millimoles of solute present in milligrams of solvent. Similar to molality. Number of millimoles of solute present in 1 ml of solution. Similarly here, millimoles of solute, if you take here, milligrams of solute we have to take. Okay, grams we have to take. Sorry, grams we have to take. Okay, right, millimoles, if you take here, grams we have to take. Okay, next one. So molality is equal to number of moles of solute by weight of solvent in kgs we have. Okay, this we can write as number of moles of solute by weight of solvent, if you write in grams, weight of solvent in grams, if you write into what we get? 1000. So from this also you can verify number of moles of solute into 1000 gives what? Number of millimoles of solute. Number of millimoles of solute. So number of millimoles of solute by weight of solvent in grams. Here you write number of millimoles of solute by weight of solvent in grams. Number of millimoles of solute by weight of solvent in grams. So if you write weight of solvent in grams, we have to multiply with 1000. Or molality is equal to number of moles, we can write as weight by molecular weight into 1 by weight of solvent. Okay, this is what? Weight of solute. Weight of solute by molecular weight into 1 by weight of solvent in kgs. Weight of solute by molecular weight, number of moles means weight by molecular weight into 1 by weight of solvent in kgs. And now molality is equal to weight of solute by molecular weight of solute into, if you write weight of solvent in grams, 1000 by weight of solvent in grams. Just we are writing number of moles weight by molecular weight. Number of moles we can write as weight by molecular weight. What is the relation between molality and molarity? Okay, you just remember the relation between molality and molarity. Molality is equal to molarity into 1000 by density into 1000 minus m dash. Molality is equal to m into 1000 by d into 1000 minus dash, where capital M is molarity. This is the relation between molality and molarity. Capital M is molarity, d is density, and m dash is molecular weight. Molecular weight in grams. Okay, m dash is molecular weight. So this is about molality and next one, seventh one, ppm. Okay, this ppm or ppb scale generally we follow. Okay, when we follow ppm or ppb scale and ppm or ppb scale. Okay, ppm means what? Parts per million. This is parts per billion and okay, when we follow ppm or ppb and whenever solute present in very small quantities, trace quantities, if solute present in trace quantities, if solute present in trace quantities, small quantities, in such cases we express their concentration in terms of ppm or ppb and whenever solute present in trace quantities, in such cases their concentration we can express either with respect to ppm or ppb and for very low concentrations, still very low concentrations we follow ppb and compared to ppm, still for very low concentrations we follow ppb scale. Okay, generally this scale we follow for pollutants to express the concentration of pollutants in water or air and to express the concentration of pollutants present in water or air. Okay, we follow these scales and ppm or ppb scale. Okay, now what is ppm and the name itself indicates parts per million. So it is the number of parts of solute present in million parts of solution. Percentage means only it is the weight by weight percentage. It is the weight of solute present in 100 grams of solution. Percent means 100 we have to take solution. Here million means million parts of solution. 10 power 6 parts of solution we have to take. In 10 power 6 parts of solution, how many parts of solute present? In 10 power 6 parts of solution, what is the number of parts of solute present? That is called as ppm. Right, ppm. It is the number of parts of solute. It is the number of parts of solute. It is the number of parts of solute. It is the number of parts of solute present in. It is the number of parts of solute present in 10 power 6 parts of. It is the number of parts of solute present in 10 power 6 parts of solution. 10 power 6 parts of solution. That means million parts of solution. 10 power 6 means what? Million parts of solution. Okay. Again, this ppm may be expressed either with respect to weight by volume. It may be expressed volume by volume or weight by volume also. It is expressed in three ways: weight by weight, or volume by volume, or weight by volume. For example, it is the amount of solute in grams. It is the amount of solute in grams present in 10 power 6 grams of solution. Okay, or it is the volume of solute in ml present in 10 power 6 ml of solution. It is the weight of solute in grams present in 10 power 6 ml of solution. Okay, solution we have to take 10 power 6 %. Okay, you may express W by W or V by V or W by V. Okay, for example, if you take with respect to W by W, it will be given like this only. ppm is equal to weight of solute in grams by weight of solution in grams into 10 power 6 and 10 power 6. For percent we will get into 100, for million we will get into 10 power 6, and that is the difference. Similarly, volume of solute in ml by what we get? Volume of solution in ml into 10 power 6. Okay, and so on. That is about ppm. One ppm is equal to nothing but 1 milligram per liter. 1 ppm is nothing but 1 milligram per liter. 1 milligram per liter ante how many grams are present? 10 power minus 3 grams per liter. Okay. Per liter. That means 10 power minus 3 grams per how many ml? 1000 ml. That means 10 power minus 6 grams per ml. You can write like that. 1 ppm is nothing but 1 milligram per liter. 10 power minus 3 grams per liter. So 10 power minus 3 grams per 1000 ml or 10 power minus 6 grams per ml. If 10 power minus 6 grams present in 1 ml, what is its ppm once you check andi. Okay. Here what? 10 power minus 6 per 1 ml. Okay, volume, weight by volume if you take, weight by volume if you take, weight of solute that is 10 power minus 6 by volume of solution that is 1 ml into what we have 10 power 6, 10 power plus 6 minus 6 gets cancelled. What we get? 1 ppm will get. So therefore 1 milligram per liter is nothing but what? 1 ppm. Okay. Next one andi ppb. ppb. How can you define it? Now it is the number of parts of solute present in what? 10 power 9 parts of solution, billion parts of solution. Okay, it is the number of parts of solute present in 10 power 9 parts of solution. So simply in the place of 10 power 6 what we get? 10 power 9 we will get. ppb. It is the number of parts of solute present in 10 power 9 parts of solution. 1 ppb is equal to 1 microgram per liter. 1 microgram, that means 10 power minus 6 grams. You know? One ppb is equal to 1 microgram per liter. Previously 1 milligram per liter, now it is 1 microgram per liter. Okay. Okay, 10 power minus 9 grams per 1 ml means how many ppm? ppb it's only 1 ppb. Okay, here weight we are taking 10 power minus 9, volume we are taking 1 ml into what we have 10 power 9. So 10 power 9 plus 9 minus 9 gets cancelled. So we get 1 ppb. And the relation between 1 ppm and ppb is 1 ppm is equal to 1000 ppb and 1 ppm is equal to 1000 ppb. Just you have to possess some idea on ppm, ppb, not much important. Okay, right. 1 ppm is equal to 1000 ppb. Okay, micrograms means what? 10 power minus 6 grams. Milligrams means 10 power minus 3 grams. Okay, over. Next one, strength of solution. What about strength of solution? So weight percentage means it is the weight of solute present in 100 grams of solution. Strength of the solution means it is the weight of solute present in what? Or amount of solute in grams present in 1 liter of solution. Okay, it is the weight of solute or amount of solute in grams present in 1 liter of solution, right? It is the amount of solute, in grams, present in 1 liter solution. It is the amount of solute in grams present in 1 liter solution. So what we get, and strength of solution is equal to weight of solute in grams, by what? Volume of solution in liters. Okay, and for example, in V liter solution, W grams of solute present. In V liters solution, W grams of solute present. Now we want to calculate for how many liter solution? 1 liter solution. So in 1 liter solution, what is the weight of solute present? That is weight of solute in grams by what? Volume of solution in liters. Okay, weight of solute in grams by volume of solution in liters. See the expression for strength. Or if you write in ml, volume of solution in ml, we have to multiply with what? 1000. If you write in ml, we have to multiply with 1000. Okay. With respect to molarity also we can write and strength. Molarity is equal to what we have? Number of moles by volume in liters. Number of moles means weight by molecular weight into 1 by volume in liters. Weight by volume in liters is called what? Strength. So molarity is equal to what? And strength of the solution by molecular weight. Okay. Molarity is equal to number of moles by volume in liters. Number of moles means weight of solute by molecular weight of solute. Okay, volume by weight by weight of solute in grams by volume in liters. That is nothing but strength. So molarity is equal to strength of the solution by molecular weight. So this is the concept of strength of solution. One more term is there, formality. And when we follow formality, we follow for ionic solids. Formality we follow for ionic solids, or where solute undergoes dissociation. Okay, for example, okay, briefly I am explaining formality. For example, if you take NaCl and if you add 1 mole of NaCl to water, after adding 1 mole of NaCl to water, in water how many moles of NaCl present? 1 mole of NaCl is not present. 1 mole of Na plus ions, 1 mole of Cl minus ions are present. Okay, in such cases we follow formality. Okay, so here NaCl undergoes dissociation. NaCl undergoes dissociation to give Na plus ions and Cl minus ions. We are adding 1 mole of NaCl molecules, but in the solution what are present? 1 mole of Na plus ions and 1 mole of Cl minus ions. So whenever solute undergoes dissociation, in such cases to express concentration we follow formality. Okay, almost similar to molarity only. Okay, similar to molarity only that we follow for ionic solids or the solutions where solute undergoes dissociation. And last one, normality. Okay, some big concept, normality. Normality. What is normality? It is the number of gram equivalents of solute present in 1 liter solution. It is the number of gram equivalents of solute present in 1 liter solution. Okay, molarity means number of moles of solute. Here number of gram equivalents of solute we have to take. Molarity means number of millimoles of solute present in 1 ml solution. Here number of milligram equivalents of solute present in 1 ml solution. Okay, so normality is nothing but number of moles of solute present in 1 liter solution or number of millimoles of solute present in 1 ml of solution. Okay, write the definition. Normality, it is the number of moles of solute. It is the number of moles of solute. It is the number of moles of solute present in, no. It is the number of gram equivalents. It is the number of gram equivalents of solute. It is the number of gram equivalents of solute present in, it is the number of gram equivalents of solute present in 1 liter solution. It is the number of gram equivalents of solute present in 1 liter solution, or it is the number of milligram equivalents of solute. It is the number of milligram equivalents of solute present in 1 ml solution. It is the number of milligram equivalents of solute present in 1 ml solution. It is the number of milligram equivalents of solute present in 1 ml solution. So the formula for normality. Okay, for example, in V liter solution, n gram equivalents of solute present. N gram equivalents of solute present. Okay, in V liter solution, n gram equivalents of solute present. Then what about in 1 liter solution? Then what about in 1 liter solution? That is, normality is equal to number of gram equivalents of solute by volume of solution in liters. Number of gram equivalents of solute by volume of solution in liters, or we get number of milligram equivalents of solute. If you take number of milligram equivalents of solute by volume of solution in ml, number of milligram equivalents of solute by volume of solution in ml. So therefore, what is the unit? And unit is, normality can be represented simply by n. Normality can be simply represented by n, or gram equivalents per liter, gram equivalents per liter, or gram equivalents per decimeter cube. 1 liter we can write as decimeter cube, gram equivalents per liter or gram equivalents per decimeter cube, or milligram equivalents per ml, milligram equivalents per ml, or milligram equivalents per centimeter cube, milligram equivalents per centimeter cube. Gram equivalents per liter or gram equivalents per decimeter cube, or milligram equivalents per ml or milligram equivalents per centimeter cube. Whether it depends on temperature or independent of temperature? Depends on temperature, right? It depends on temperature. It depends on temperature. Next, if you see various expressions for normality, similar to molarity, and various expressions for normality are, normality is equal to, one is number of gram equivalents by volume of solution in liter, number of gram equivalents by volume of solution in liter, or number of gram equivalents by, if you write volume of solution in ml, volume of solution in ml, what we get into 1000. If you write volume of solution in ml into 1000. So number of moles we can write as weight by molecular weight. Number of moles we can write as weight by molecular weight. Similarly, what about number of gram equivalents? Number of gram equivalents we can write as weight by gram equivalent weight. Equivalent weight in grams. Number of gram equivalents is equal to what? Weight by equivalent weight. So later I will explain how to calculate equivalent weight of a given substance. At this moment you just remember number of gram equivalents is equal to weight by equivalent weight. So next I will explain, later I will explain how to calculate equivalent weight. Okay. So normality is equal to, we get number of gram equivalents we can write as weight by equivalent weight, weight by equivalent weight into 1 by V in liters, or weight by equivalent weight into 1000 by volume in ml. weight by equivalent weight by weight by equivalent weight into 1000 by volume in ml. Here we can write with respect to strength also, no? Here we can write with respect to strength. Weight of solute in grams by volume in liters. That is nothing but what? Strength. Okay. So normality is equal to what we get? And strength of solution by what we get? Equivalent weight. In the case of molarity, strength of solution by molecular weight. Strength of solution by molecular weight. Here, strength of solution by equivalent weight. Next, similarly, you convert into weight by volume percentage, weight by weight percentage. After that, dilution principle, all the same and similar to molarity we have. Now convert into weight by volume percentage. Convert into weight by volume percentage. See here, weight of solute by volume of solution in ml into 100. That we can write as what? Weight by volume percentage. So normality is equal to, we get weight by volume percentage into 10. 1000 we are writing as 100 into 10. By what we get? Equivalent weight. In the case of molarity we will get molecular weight. In the case of normality we get equivalent weight. See the difference. Similarly, that if you convert into weight by weight percentage, what we get in the molarity? In the case of molarity, what we got? Weight by weight percentage into 10 into density by, we got molecular weight. In the case of molarity, here we get equivalent weight. Or we can write like this also, purity into 10 into specific gravity, purity into 10 into specific gravity by equivalent weight. Purity into 10 into specific gravity by equivalent weight. Okay, so with respect to strength of the solution, with respect to weight by volume percentage, with respect to weight by weight percentage, these are the expressions for normality. Next, you write the expression for number of gram equivalents of solute. Next one, number of gram equivalents of solute. How to give a number of gram equivalents of solute? N into V in liters. N into V in liters. Okay, number of gram normality is equal to what? Number of gram equivalents by volume in liters. So number of gram equivalents is equal to what? N into V in liters. N into V in liters, or if you write volume in ml, number of gram equivalents is equal to what? N into V in ml by 1000. N into V in ml by 1000, or N into V in ml by 1000. N into V in ml by 1000. That is the expression for number of gram equivalents. Now what about the expression for number of milligram equivalents? Number of milligram equivalents of solute. What is the formula for normality? Number of milligram equivalents by volume in ml. Number of milligram equivalents by volume in ml. So number of milligram equivalents is equal to what? N into V in ml. N into V in ml. This is the number of milligram equivalents of solute. Or can write as what? Number of gram equivalents into 1000. Milligram equivalents what means what? Number of gram equivalents into 1000. That means N into V in liters. N into V in liters into 1000. N into V in liters into 1000. That gives number of milligram equivalents of solute. So next one, dilution principle. Dilution principle. So during dilution, previously what we have, is there any change in the number of moles and millimoles of solute or no change? No change in the number of moles and millimoles of solute. Similarly, during dilution, no change in the number of gram equivalents or milligram equivalents of solute during dilution. That is the dilution principle. And similar concept we have, right? Right? During dilution, number of gram equivalents, during dilution number of gram equivalents or number of milligram equivalents, during dilution number of gram equivalents or number of milligram equivalents of solute remains constant. During dilution number of gram equivalents or milligram equivalents of solute remains constant. That is N into V is equal to constant. If you take V in liters, we will get gram equivalents. If you take V in ml, we get milligram equivalents. So that is N into V is equal to constant, or N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. Okay, similar to previous case, if you have stock solution, concentrated solution, if you want to prepare dilute solution, in such cases we follow this dilution principle. Okay, what is the volume of solvent to be added? What is the volume of solvent to be added? Volume of solvent to be added during dilution. Volume of solvent to be added during dilution is nothing but what? V2 minus V1. Volume of solvent to be added during dilution, that is V2 minus V1. For example, this is the stock solution we have. For example, this is the stock solution we have. 10 normal, okay, HCl solution we have. 10 normal HCl solution we have. Our required solution is 100 ml of 1 normal HCl solution. For example, the stock solution is 10 normal HCl solution. Our required solution is 100 ml of 1 normal HCl solution. 100 ml of 1 normal HCl solution. So now N1 V1 is equal to N2 V2. Okay, N1 value is 10. V1 we have to calculate what is the concentration of, what is the volume of stock solution we have to take, that we have to calculate. Required concentration is 1, required volume 100. V1 is equal to 10 ml. V1 is equal to 10 ml. So therefore, what about the volume of water to be added? 100 minus 10 ml, that is 90 ml of water. So to 10 ml of 10 normal HCl solution, if you add 90 ml of water, what we get? 100 ml 1 normal HCl solution we will get. To 10 ml of 10 normal HCl solution, if you add 90 ml of water, we will get 100 ml 1 normal HCl solution. Next one, Andy. Next what we discussed, Andy. If V1 ml of solution 1 whose concentration is N1, okay, we are mixing with what? V2 ml of solution 2 whose concentration is N2. These two we are mixing, and V1 ml of solution 1 and V2 ml of solution 2 we are mixing, okay, and we are preparing a solution. This is the resultant solution. This is the resultant solution. What about its concentration? What is the formula, Andy? Resultant solution concentration or normality is equal to what? N1 V1 plus N2 V2 by V1 plus V2. Okay. So what is the number of milligram equivalents of solute present in first solution? The number of milligram equivalents of solute present in first solution is N1 V1. The number of milligram equivalents of solute present in second solution is N2 V2. So in the resultant solution, total number of gram equivalents is milligram equivalents is N1 V1 plus N2 V2 by total volume of solution, that is V1 plus V2. Okay. If you add some water also, I can this one. Okay. After this, you write this one also. X ml of water. We are adding X ml of water also. Then what is the resultant solution? Normality and N1 V1 plus N2 V2 by V1 plus V2 plus Xn. N1 V1 plus N2 V2 by V1 plus V2 plus X. Okay, previously we considered a reaction like this and N moles of A plus N moles of B gives rise to, for example, product and some C. Okay, product. Okay, this reaction we considered. What about the ratio of number of moles of A by number of moles of B and A? That is, let us consider this is Na, this is Nb. So number of moles of A by number of moles of B is what? Na by Nb. Number of moles of A by number of moles of B is Na by Nb. Okay, but if you consider a reaction, okay, same reaction, if you consider the same reaction, what about the number of gram equivalents of A, number of gram equivalents of B and the number of gram equivalents of product and okay, the number of gram equivalents of A is equal to number of gram equivalents of B is equal to number of gram equivalents of product and okay, that is the advantage we have with the number of gram equivalents. Number of moles may be different. Number of moles of A is different from number of moles of B and number of moles of product. But what about number of gram equivalents and same, number of gram equivalents of A is equal to number of gram equivalents of B is equal to number of gram equivalents of product and or number of milligram equivalents of A is equal to number of milligram equivalents of B is equal to number of milligram equivalents of product. Always during a reaction, okay, always during a reaction, the ratio of number of gram equivalents of reactants should be 1:1 and okay, or number of ratio of number of gram equivalents of okay, all the reactants and the product should be same and okay, write that point. During a reaction, okay, number of gram equivalents of A, number of gram equivalents of A is equal to number of gram equivalents of B is equal to number of gram equivalents of product P during above reaction. Otherwise you write during above reaction number of gram equivalents of A is equal to number of gram equivalents of B is equal to number of gram equivalents of product. Always reactants react in 1:1 ratio of their equivalents. Always reactants react in 1:1 ratio of their equivalents. That means 2 gram equivalents of A reacts with 2 gram equivalents of B. 3 gram equivalents of A reacts with 3 gram equivalents of B. Always reactants react in 1:1 ratio of their gram equivalents. Write that point. Always reactants react in 1:1 ratio. Always reactants react in 1:1 ratio of their gram equivalents. Always reactants react in 1:1 ratio of their gram equivalents. Okay, number of moles may not be 1:1 and but number of gram equivalents should be 1:1 and that is the difference. Here Na by Nb, but it is not equal to 1 by 1. It is not equal to 1:1 and it may be 1 mole, this may be 2 moles. It may be 2 moles, it may be 1 mole, whatever it may be. but it is not 1:1, but the number of gram equivalents should be 1:1 అండి, right? These are some concepts from normality అండి. So still we have only one concept from normality, that is how to get equivalent weight అండి. How to get equivalent weight, that we will discuss in the next session, and we will discuss some questions based on various methods to express concentration అండి, right? Now take